All right, I'm back. Here is example number 2 from day 129 notes. All right. So, you know what? You might just want to pause the video and see if you can figure out this on your own, just to kind of test yourself and see if you've got a better understanding than you might think. Okay? So pause it. Unpause. All right. Here we go. Let's check this out. So I'm going to start with -9. So we're talking from the left, from the right, at that spot itself, and then what's the function how's the function actually behaving, not what it's approaching. So -9, 1, 2, 3, 4, 5, 6, 7, 8, x equals -9. There's a lot of behavior going on right here. So from the left, we're talking about this horizontal line. It is matching up with the y value 1, 2, 3, 4, 5, 6, 7, 8. So it is vertically 8 units up when x approaches -9. Okay. Hopefully it's clear to you guys that from the right it's doing the exact same thing. It's coming up here and it's resting solely on y equals 8. 1, 2, 3, just double checking. 1, 2, 3, 4, 5, 6, 7, 8. Got it? All right, now, when the left and the right converge to an actual point, it does not matter whether the point is filled in or if it's an open circle. It is equal to 8 at that spot. That's the function from the left and the right approaching to the value y equals 8. But the function doesn't actually equal 8 at x equals -9. Part D, f of -9 means when I literally plug in x equals -9 into the function f of x, I get the y value 1, 2, 3, 4, 5, 6. Okay? When we talk about the x value -1, 2, 3, 4, 5, 6, when x equals -6, from the left it goes to the y value 1, 2, 3. From the right, it's headed to the same spot, which means x approaches -6. The limit is actually the same value as these two previous to it. But the function doesn't actually live there. The function does not live at y equals 3. Since it's an open circle with no discernible x value dots just randomly thrown in there, it's an undefined value on this function. Undefined. Okay. Let's move on to let's move on to -2 now. So -2, we're talking about another asymptote. Okay. From the left, you guys should be talking about a car that never crosses that river. It's always going north. It's always going to a bigger value. This is going to be positive infinity. From the right, it's going to be the same. It's not the same number though. That it's like when they're getting closer to each other incrementally. It doesn't necessarily mean like when it's 1/10 of a unit away on the left, it's the same as 1/10 of the unit away on the right. We don't know how it's behaving from the right except that it just keeps getting larger. Right. Which is another reason why you can't say that it converges to a specific y value at that point. They're never going to cross over this river. They're never going to cross over this asymptote that's separating the two. They're forever separated. So that limit does not exist, and you really don't have a definable y value when x equals -2 because there's no like, I just want to say dot. Like the dot represents where a function actually lives at a certain spot. So it's undefined. All right, the next point of interest would be at 2. which it's basically a repeat of the last video, that last exercise. We've got an asymptote from the left forever moving northward, which just means, hey, you're stuck at positive infinity. You're just going to keep going farther and farther up on the y-axis. From the right, you're forever going down, 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 so it's going negative infinity. And again, the behavior from the left and the right is what's informing the limit at that particular spot. So it's not informing them of a specific meeting point. It's just saying you got randomness moving up and you got randomness moving down. Randomness wasn't the right word to use there. More like unquantifiable increase, unquantifiable decrease. Once you get to those infinite values, it doesn't exist. All right, but then the function does actually live there. The function lives there. The limit does not exist. The function lives at 1, 2, 3, y equals 4 when x equals 2. All right, now, when x equals 5, this is kind of a new situation. It did show up on the last graph, but I didn't talk about it. What happens when they, from the left, are going to different spots where we're not talking about infinite values? Well, from the left and the right, nothing really new is happening. It's when x approaches 1, 2, 3, 4, 5 from the left, it lives at the y value 2. When you approach it from the right, the y value is -1. So hopefully that makes sense to you guys. We're just following it from the left and the right at that point. Again, use the metaphor of where are these two function cars, kind of like they're driving towards something. Do they meet? They do not meet. There's not like a place to fill in the spot where they're approaching meeting. When they don't match from the left or the right, then the limit doesn't exist at that spot. So the limit as x approaches 5 does not exist. But then when you're talking about where does the function live, not where the limit, but where the function lives, there's a filled in circle. Remember, we're just talking a point here, not like a two-dimensional circle here. At 5, it actually equals 2. All right. Now I do want to talk about the infinite behaviors as well. Let me check over the document. Yeah, U and V. Let's see. Can you guys see that over here? U, V. Yeah, you can see it. The limit as x approaches positive infinity, and the limit as x approaches negative infinity. I think this will do it. Yeah, there we go. If we're talking about positive infinity, remember, horizontal asymptotes, if you spot them, they are very important for this. This, the author intended to level it off there, so there is a horizontal asymptote right here. It's approaching 1. It's never going to be above 1 on the y as its y value. And it's getting ever so close to it. As you go to negative infinity, you keep moving left on the graph, it's pretty much staying as a constant right on y equals 8. Remember, it was 1, 2, 3, 4, 5, 6, 7, 8. So if it's at 8 here and just continues on that, it's going to be 8 as we go to negative infinity. So it's interesting. You don't have to have, I think in the last example we had at least, like one of them was negative infinity. You don't have to have an infinite y value to approach negative or positive infinity. All right, I think we'll call it a day with that one. Hopefully these videos are at least somewhat helpful to just introducing this idea of how you find limits computationally, or how you find limits when you're trying to just visually graph them.